Hey everybody, how's it going? So, as I said, I'm trying to get back to doing regular board repair videos like I used to do. It's been a little bit difficult to find not even so much the time as much as the space. But Camille is a very, very kind, nice person who works here, who helped make a separate space for board repair so that now we could fit him in another part of the store so that he can do data recovery in a space that I used to occupy, and I can have my desk back and I can do board repairs again. So we are going to try to have an informative board repair video. I would like to go back to what I hoped for earlier in the year, which is an informative board repair video every day. So let's take a look at this machine. Now, this here is the MacBook. We have got the power unplugged from it. We have the battery unplugged from it. So as I say in many of these videos, the first troubleshooting step that I usually go for is seeing how much power the machine is taking. So let's take a look and see what we get. I'm gonna turn on the power supply software so that you're all able to see what's going on the screen. So we're just gonna hit the little meter button. It's gonna turn this on, and you'll be able to see how many amps the system is taking. So we plug it in, and when plugged in, it seems to be taking 6 to 12 milliamps. Now that's an interesting number because 24 milliamps typically means that the S4 is an upper missing. PM Sleep S4L is not there for whatever reason. 200 to 300 milliamps typically means that something on PP bus G3 hot is shorted, or all the SO rails are on and one is missing, or when you have ALSYS power good issues, you'll have about 100 to 200 milliamps being taken. 12 milliamps, 6 to 12 milliamps, it's actually a new issue. I've never experienced that before, and I'm kind of curious as to why that's happening. So we're going to take this out, and let's see what happens from there. So let's just get the board out of the casing here.
It's after hours, fuck that shit. Alright, so we bring this? Yeah, bring them. You have some. I have some wine. Fuck you. Really? Okay, so don't bring them.
Are you trying to get people drunk after hours so that you could take advantage of them?
Whoa, Epstein, calm down.
You fucking Epstein. I heard you say, no, it's after hours. Oh yeah, we got wine.
No,
Come on over.
I'm like, it's after 8.
Also, what is this power?
After 8.
Anyway. So what we're going to do now is we're going to measure for some basic voltage rails in the multimeter. Let's turn on the meter. Let's turn on Paul Daniels' execrable multimeter software, which never works. Today is no different. All right. It seems like we've got the Paul Daniels software to turn on. Look at that. What a miracle. Now, we're going to measure some power lines and see what's present on this MacBook. So we're going to plug it in. The first rail we're going to measure is PP bus G3 hot. For those of you who are curious why it is that I would measure PP bus G3 hot, let's just open this up in the schematic and the board view so that you can get an idea of what I'm doing here. This here is an 820-00165, which is written right under the SSD. If you're wondering how you could tell what where the model number of your motherboard is, well, it's in a different place in every board. So I need to know what your board number is before I can tell you where to find it. But in order to tell you where to find the number, I need to know the board model number. But in order to know the board model number, you need to know where to find it. But in order to know where to find it, you need to know the board model number. Much Apple. Why put it on the standardized place on every machine when you can have it on a different place every single time? MacBook. Now, as you can see here, there's a list of power rails on the screen. And when there's a no power situation, what I want to do is go through the list of power rails on this page here. This page is called Power Aliases. See that? Power Aliases. We're going to go through that page, and we're going to find which one is missing. Now, the G3 hots are the ones that need to be present first. And as many of you know, PP3V42 needs to be present before any of the other rails. PP3V42 needs to be present because that's the rail responsible for the one-wire circuit. And the one-wire circuit is going to be what allows the SMC on the board to speak to the charger, which gets us a green light. So as you can see, right now, the charger has no green light on it. And this charger needs to speak with this SMC, and they have to say, "Hi, I'm a MagSafe charger. Hi, I'm a MacBook. Oh, turn yourself on. Are you an original charger?" Yes, I am an original charger. So we're going to check and see where it is that PP3V42_G3 hot is. And in Paul Daniels' lovely Flex board view, I right-click, and it shows me everywhere that I can find it. It's beautiful. Now, what I usually do to save some time is I measure on the largest component there is because it's going to be the easiest one for me to spot from my eyes. When I used to teach, When I used to do the board repair classes in 2015, 16, and 17, one thing I noticed is that it would take people a really long time to find the power rail or to measure it. I always want to measure on the largest, most obvious place. So we're going to do that here. Let's just change over to the desk camera again and see what we get on our PP3V42. Looks like we get 2.9 volts. 2.9 volts is no good. That's not what I'm expecting. I'm expecting 3.4. Now, it's close to what I'm expecting, but not quite. So I don't know. I don't think it's not being created. If I had to go through the list of different reasons that my power rail could be missing, I've gone over this in a guide that you can link. You can see in a link down below, a beginner's guide to board repair. That the chip that makes the rail is not being enabled. It is because it's trying to turn it on, and it's like 90% of the way there. So that's not it. The chip itself could be bad. Likely, or there's a short circuit to ground that's pulling it to ground. But this could be a partial short, not a full short. And when I say short circuit to ground, rather than the power line going where it's supposed to, it's going down to ground, which is going to be where, electricity goes to die. Long-time viewer. Love what you do, Lewis. Thank you very much. I highly appreciate that. So let's see what we get on PP3V42 to ground. 10 kiloohms. Well then. 10 kiloohms to ground, which is clearly not going to be short-circuited. And it's going up, actually. Strange. I'm usually expecting a higher resistance to ground, but 10 kiloohms would not explain what we have here. It would not explain the fact that that circuit is only putting out 2.9. Your work is art. Do you realize that? It doesn't feel like art, but thank you very much for giving me some happy, positive feedback there. So let's take a look at that area in this beautiful microscope. It looks like we have a coil. It looks like some pubic hair. Just get rid of all this rubbish. So many little pubic hairs in this area. Alright, we're going to take a look around the board and see if anything strikes us as odd before continuing. Nothing on this board looks strange at all. Nothing. Let's plug you back in. Check our PP3V42. Oh, voltage, duh. 2.9. Strange. Yeah, I've never had that before, to be honest with you. That's confusing. Alright. So, let's see if the proper voltage is going in. $17 volts is going into the chip, as I would expect. Let's take a look at that PP3V42 circuit, shall we? Don't see anything wrong here. I mean, there's pubic hair, but pubic hair is to be expected in a MacBook. Has the supervisor from USPS called back? No, they haven't. You know what the fucked up thing is? In that video, I said that the postwoman that does the normal pickup is the best. They're kind. They do their job properly. It's when she takes a day off that stupid things happen. And everybody at that post office is actually blaming the one person that I said was good, which really makes me sad. So that supervisor is blaming her for the fact that he fucked up. And everybody at that post office is apparently blaming the person who was not even there, who I mentioned in the video and said was very good at their job. It's sad, but it's USPS. Alright, so we're going to take a look at that PP3V42 circuit. This is being a troll. So the whole idea is this chip wants to know how much power it is putting out. So this over here is the 3.42 volt power supply. Now this chip wants to know, what am I outputting? You know, am I putting out too much, too little? So it has this pin called feedback. And what the feedback pin is going to do What the feedback pin here is going to do is the chip is going to see what it's outputting, and some of the output gets sent over to feedback. Now, it's not all the output that gets sent over to feedback because there's a voltage divider over here. So if this voltage divider fails in a manner where the top resistor has, let's say, less resistance, then, which never happens, then it's going to send too much to feedback. The chip is going to think it's making too much power, therefore you're going to get less voltage, which is what's happening. If the bottom, let's say if this resistor fails and stops outputting anything, then the chip will think, oh, I'm getting nothing, put out way too much power. And if the bottom resistor were to fail or die, it wouldn't drop the voltage at all. It would send straight 3 volts instead of less to feedback. The feedback would be too high, which means it would lower the voltage on output. So what we're getting is a lower voltage on output, which makes me wonder if R7096 is working or not, or if it's decreasing everything too much. So let's just turn the meter on, and we're going to take a look in here and see what's happening. Remember, if R7096 over here, the whole idea with this feedback circuit is it wants to see, am I putting out too much power? Now, it's apparently the feedback, I'm guessing, because there's a voltage divider outputting to it, and a voltage divider's purpose is to decrease voltage. If a voltage divider is sending voltage there, obviously it's not measuring exactly what it's sending, it's measuring a fraction of what it's sending, because that's the way it was designed, with a voltage divider for feedback. So if the voltage divider is not working and it's sending too much power to feedback, then it will think, I'm putting out too much power, let me lower the voltage I'm putting out. And R7096 would be what I suspect at that point. So let's take a look at R7096 and see if it's measuring the 200 kilo ohms it's supposed to, which it probably will be. This is probably going to be a big giant troll, but let's see. So that's supposed to be the 200 kilo ohms, and yeah, it's going to be 200 kilo ohms. That's just fine. Now, I still am wary of this idea that I have 10 kilo ohms to ground on PP3V42. I'm not used to that. That seems, again, that's not going to lower it. It shouldn't lower it, but it should be higher than 10 kilo ohms to ground. Something strange is happening there. This is our SMC reset chip that's on that same line. As you can see, it's got some pubes there. SMC, which is on that line, pubes, clock chip, clean. Yeah, this is going to be a tough one. I'm going to guess that my issue is going to be that 10 kilo ohms to ground on this is inappropriate. So I'm going to... excuse me. So I'm going to try on another one. I'm going to grab another 34... 00. You like?
I like it.
I'm glad. So let's check on another 00165 and see what resistance is to ground for PP3V42 on that one. So I'm going to grab another one, put it on my lap, and just check it out real quick and see what the resistance to ground is. Battery's not plugged in or anything. Okay, 10.95, so that's not the case. So this is purely a troll. Let's see if when the circuit has been warmed, if it works any differently. I'm getting a green light now. I'm getting a fan spin. Check that out. So green light and fan spin. Now, I didn't see any broken solder joints there, so I'm not convinced that there's a problem with the solder joints because they all look just fine to me. Sometimes if you have a dead chip, you can actually make that chip work again by heating it. It's a common issue. Now, this happens with tantalum capacitors. However, there's only one tantalum capacitor there, and that's for the inrush one. This wouldn't even need that to work right. The other thing that it could be is the actual regulator itself. So I'm going to replace that regulator with another one. And this pretty much was a chip that most likely failed. I'm not going to leave it like this because there's a good chance that this dies again and returns if I don't replace the chip. The lazy thing to do would be to leave it there, but that would be kind of mean. So this seems to be a case of a chip dying, and heat did revive it. Now, one of the reasons that I'm really against the oven method for repairs rather than this is that, let's say the oven, quote, fixed this, end quote. How would you actually know what the issue is? The oven, when people say they put something in an infrared oven and it worked coming out of it, one of the reasons that I don't like that method is because you haven't actually figured out what the issue is. Now, that the oven method may make sense if you're dealing with something that is a product that does not belong to you, or a product, I should say that again. I correct myself. If you're dealing with a product that does belong to you, not to a customer, so that there's not somebody who's going to be screwed over if you do the wrong thing and don't fix it. Or if you're dealing with something that is so cheap that you cannot apply brains to it because it's not economically viable to apply brains to that particular problem. We do that. But see here, even if the oven did make something work again, whatever it made work again is going to fail soon thereafter, and the reason it's going to fail again is because you never actually figured out the cause of the problem. It's like taking a painkiller because you're sitting in a chair at work that has a bump in it because, let's say, there's a rock in it. You want to remove the rock from the chair rather than take a painkiller. And that's one of the issues that I have with taking taking the board and putting it into some sort of infrared oven. I remember having a student 3.5 years ago that said, yeah, I take everything and I use infrared oven and I'm going to do it since it works. And then I remember hearing back from him later saying, oh, I had this board, I put it in the oven, and now this, that, and the other, and it doesn't work. And it's like, yeah, because you didn't fix it. You didn't, put the effort in, do the work, and figure it out, and then your customer won't come back. So I'm just looking for my desoldering wick. Perhaps I lost it when I moved from the front to here. Never mind. Here we go. Also, everybody, please do say hi to Paul Daniels in the chat. Paul Daniel hails from the land of Australia. Paul Daniels is a VIP in this chat because he put together the software that allows the multimeter to show up on the screen, as well as this lovely board view software that makes my life so much easier. It really does. It's great stuff. There's an open source free version, and then there's the version that with all these little enhancements that we complained about until we got over time, so he charged us for it. But he's a good dude. You should check out his website. He does fix MacBooks in Australia. It's the coil. It is not the coil, Paul Daniels. Paul Daniels does fix MacBooks in Australia. So if you are looking for this type of service and you are in Australia, I would suggest giving him a look rather than sending it to another country, which is going to cost you a lot of money. So we're just going to replace this chip. Now I wicked away I added leaded solder. Then I wicked it, make it easy to remove. I wicked it away. I added new solder. And now I'm going to take a chip from a donor. If I didn't have a donor, I would go to store.rossmangroup.com. You can find the chip LT3470 or U7090. If you buy it, there's probably a good chance it'll just get lost by the post office, though, anyway. So, not really sure how comfortable I even feel shilling anymore. No package is safe. All right, this is interesting. So I'm using what used to be Camille's desk, and apparently he's using a tweezer tip on the micro pencil. So I'm just going over each joint again. There we go. We plug it in, green light, fan spin, and it works. So that's that. This board most likely was having an issue with the 3.42 volt circuit. When we heated that area, the chip started to work again. I'm not going to trust that chip to work again. I just put another one, and that works. Beautiful. Now, on this machine, I don't have a schematic for the DC in board, which the charger plugs into. So if I wanted to give you an understanding of how the one-wire circuit works, that's not going to work. What I actually have to do is open up a schematic for an older board, and then through there I'll be able to show you how the one-wire circuit works. So let's go ahead and do that. Over here you have the MagSafe DC power jack. This is J906900. That's where the charger plugs into the machine. Now you have three lines. You have 18 volts, you have ground, and you have adapter sense. 18 volts is power, ground is ground, adapter sense is where the thinking happens. So this is where the thinking is occurring, where the communication and all that good stuff, the brains. So over here, you have adapter sense. That's where the thinking is going to occur. And here's the thing. Adapter sense is a 3-volt data line. Here, this is an 18-volt power line. Now, you don't want, if somebody's trying to plug in the machine and they're drunk and they're staggering home and doing something like blah, 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 oh, like right before they're just about to puke, and they're getting on their computer because they're wasted. You don't want this kind of error to occur where the 18 volts touches the 3-volt data line, because then the SMC is going to blow up. So adapter sense goes to this chip where it says X and int. X is going to be external, the charger. That's a signal outside the computer. Int is internal. That goes to a signal inside the computer. That goes to sys1 wire. Now, sys1 wire, so this over here is this SMC, the system management controller. This is the chip that speaks to the charger, controls a bunch of other stuff in the machine. We don't want this chip getting 18 volts instead of 3 volts because somebody's acting like a drunken fool. So this chip over here sits as a buffer between the SMC and the charger so that if some stupid shit happens, the SMC doesn't wind up getting 18 volts punched right to its face. Now, this chip, like any chip, needs power to function, and that is going to be powered by this chip over here, which is powered by PP3V42. So this is a logic gate that's going to allow 3.42 volts to go to the VCC pin, the power pin of U6900, so that it can work as a buffer. Also, if you notice, if we go to the other page, this SMC chip over here is powered by PP3V42. So PP3V42 is what's going to power this chip. So not only is the one-wire circuit that allows the charger to communicate with the SMC going to require PP3V42, but the SMC chip that it's actually doing the communication with is going to need that. That's why it's the first power rail that I look at if I don't have a green light. If I do have a green light, then I'll check the rest of the power rails in the list. But if I don't have a green light, I check PP3V42_G3 hot first. On newer machines like the A1706, A1707, A1708, A1989, A1990, it's a little bit different. You need a power rail called PP3V3_G3 hot in order for the charger to work. And the way you tell if your charger's working, that one doesn't have a light on the charger, is by using a USB-C amp meter. This over here, this is a USB-C amp meter. So on the newer models, you have a USB-C amp meter available at store.rossmangroup.com that you plug into the USB-C charger, and if you're getting 20 volts, the charger is working, PP3V3_G3 hot is present. If it's getting 5 volts, then you check and see if PP3V3_G3 hot is present, because it may not be if it's not working. So that's about it on fixing this machine. It just had an issue with one chip. We were able to confirm it by heating it up. And with that, I'll move on to the next video. Thank you so much for watching, and as always, I hope you learned something, and I am going to be trying to put as much effort as I can, regardless of how busy it gets here at the store, to be putting out at least one board repair video, one informative video every single day the way that I used to before business went insane and I had 12 people trying to fit into this 700 square foot sardine can that I call a business. See you in the next one. Ah! Excellent at data recovery, not the best cameraman. What happened, Steve?
Dude, you lost your MacBook box right on my fucking stomach. Oh.
What do you think is gonna happen if you're standing there? Good to meet
But
you.
you didn't run through it. You went through and pushed through it. Jeez.